Have you ever interacted with a chatbot or a virtual assistant, and it just seemed to understand exactly what you wanted, even when you phrased it a little differently each time? That magical moment when your request is correctly interpreted, whether you are asking to play your favorite song or schedule an appointment, is thanks to a fascinating process in artificial intelligence. NLU models perform intent classification by mapping user utterances, which are text inputs, to predefined categories or intents, using advanced machine learning techniques. At its core, this involves transforming raw text into a numerical representation that the model can then classify into one of many learned intent labels. It is a critical step in enabling machines to understand human requests and respond appropriately. The process begins with breaking down the user's input, like a sentence, into smaller meaningful units, such as words or subwords, a step called tokenization. These tokens are then converted into numerical vectors, known as embeddings, which capture their semantic meaning. Early methods used simpler embeddings like word-to-vec or glove, but modern approaches often leverage contextual embeddings generated by sophisticated transformer models like BERT or GPT. These contextual embeddings are crucial because they allow the model to understand how the meaning of a word changes based on the other words around it. Finally, a classification layer, often a neural network, takes these numerical representations and predicts the most likely intent based on patterns it learned during its training phase. To effectively implement an NLU model for intent classification, developers first need to define a comprehensive set of intents that cover the range of user queries they expect. This also involves collecting a diverse and representative dataset of user utterances, each manually labeled with its corresponding intent. This labeled data is the bedrock for supervised learning, guiding the model to recognize the linguistic features that distinguish one intent from another. The choice of embedding technique and model architecture significantly impacts performance, necessitating careful experimentation and evaluation. One of the remarkable aspects of modern intent classification is the use of transfer learning, especially with large pre-trained language models. These models, trained on massive amounts of text data, already possess a deep understanding of language structure and semantics. By fine-tuning them on a smaller, task-specific dataset, we can achieve high-performance intent classification with less specialized training data. This approach allows NLU models to identify nuanced intent distinctions, even between very similar phrases, making virtual assistants much more effective and user-friendly. Understanding how NLU models perform intent classification reveals the intricate interplay between linguistic processing and machine learning algorithms. It highlights that the accuracy of a system hinges on the quality of its training data, the sophistication of its embedding techniques, and the architectural design of its classification model. This foundational knowledge empowers us to build more intelligent, responsive, and ultimately more helpful artificial intelligence applications that genuinely comprehend and act upon human language.